Here's one practical application in the lab of the concept of equilibrium. If you have an insoluble salt in the lab, okay, and you want to dissolve it, one way you could dissolve it is by trying to add acid to it instead. So if you can't get it to dissolve in water, one common technique you do in the lab is you add acid to it. It might dissolve, okay? And the explanation for that has to do with cases where if you have the negative ion of your salt, if the anion of your salt is a conjugate base of a weak acid, then that will have a greater tendency to dissolve. But if the anion is a conjugate base of a strong acid, adding an acid will not help in the dissolution of your salt. Okay? Let's illustrate that with silver phosphate. If you add acid to silver phosphate, you'll find that it is going to be soluble in the acid. So here's the expression for the dissolution of silver phosphate in water. Silver phosphate gives you 3 silver ions plus phosphate ions. What do you call the KEQ for this? Solid going to solutions. The KEQ for this is called the KSP of silver phosphate, right? And if you look up the KSP, you'll find that the PKSP is 16.05. So what is the KSP? If PKSP is 16.05, KSP is 10 to the negative 16.05. That's a very small number, right? 10 to the negative 16. But let's look at what happens to your phosphate. Your phosphate, okay, will react with H plus if you add an acid to your, so you have a silver phosphate solid right here, right, in a beaker, silver phosphate, and then you add HCl to that. So the HCl will provide the H plus, okay. What happens to H plus phosphate? It gives you HPO4 2 minus. What's the KEQ for that? H plus PO4 3 minus gives you HPO4 2 minus. That's just the opposite of HPO4 2 minus giving you H plus HPO4 3 minus. The KEQ for this is 1 over K3. Okay, so the KEQ for this is 1 over the K3 of H3PO4. And if you look it up, K3 for H3PO4 is, I've looked it up for you already. K3 for H3PO4 is 12.35. Okay? So the KEQ for this would be 1 over 10 to the negative 12.35. Okay, K3 is 10 to the negative 12.35. You can look up K3 for H3PO4, you'll find it's 12.35. And then if you look at this second reaction right here, what is that? That's just the opposite of K2, the second ionization step. So this is 1 over, the KEQ for this is 1 over K2. So that's 1 over 10 to the negative 7.20. You look it up, you'll find the second step for the dissociation of ionization of phosphoric acid has a Ka of 7.2. And then finally, this H2PO4 minus can further react with H plus. We're assuming you're going to add enough acid here, so your H plus H2PO4 will give you your phosphoric acid. The KEQ for this is 1 over K1. So that's 1 over 10 to the negative 2.15. So 2.15, you can look that up as a K1 for phosphoric acid. So what's the overall KEQ? If you add up these 4 reactions, you end up with silver phosphate plus H plus gives you 3 silver ions plus H3PO4. What would you get there? For the overall reaction, your KEQ is equal to the product of these 4. So 10 to the negative 16.05 times 1 over 10 to the negative 12.35 times 1 over 10 to the negative 7.20 times 1 over 10 to the negative 2.15. Okay, so our KEQ is just going to be 10 to the negative 16.05 minus negative 12.35, so that's plus 12.35, minus negative 7.20, so that's plus 7.20, minus negative 2.15, so that's plus 2.15. And that gives you 16.05 negative plus 12.35 plus 7.2 plus 2.15. That gives you 5.65. 10 to the 5.65. And that should give you inverse log. So that's going to give you 4.46. Okay, or 4.5 times 10 to the 5th. That's a large KEQ. And so silver phosphate is soluble in acid. Now, if you actually do this in the lab, okay, you'll find that silver phosphate is a yellow solid. So if you add acid to it, it will dissolve. But one thing you'll realize is if you add HCl, okay, that solid, that yellow solid might dissolve, but it's going to be replaced by silver chloride, which is a white solid, a white precipitate. Okay, and the reason why you get silver chloride is silver chloride is insoluble in water. And silver chloride will not dissolve in acid. And the reason for that is why. If you have silver chloride, you try to dissolve it in acid, okay? That would give you Ag plus HCl. Well, what do we know about HCl? You can't make it in water. So the KEQ for this is going to be very small. In fact, the Ka for HCl, okay, is at least, Ka for HCl is a strong acid, is at least, estimates range from, vary, but it's at least 10 to the 6th. Okay, so that would make your KEQ for this process small enough that the silver chloride will not dissolve as a result of adding acid to it. So practical application in the lab, if we have, let's say, a mixture of phosphate and chloride, you can separate the phosphate from the chloride, okay, by precipitating both. Add silver nitrate to the solution, so you'll precipitate silver phosphate and silver chloride, and then you add some other acid, preferably not HCl because HCl will add more chloride, but you can use HCl. You add HCl, that will dissolve the silver phosphate, and then your silver chloride will remain as a solid. And then what you do is you can separate your solution from your solid.